Hey, welcome back. We're just about to do problem 2, or day 2 of Advent of Code. Before we do, I just wanted to give a bit of a recap. The last video had us solving the problem very algorithmically. We looked at a strategy called two pointers, which allowed us to implement a very efficient solution. The one we're about to look at today is going to be a little more brute forcier. It's not really going to have so much an algorithm design component to it. It's going to be more about data manipulation. And so some of the things we're going to look at and focus on in today's video are going to be regular expressions, the JavaScript Fetch Api. We're going to look at a little bit of asynchronous code and just a touch of bitwise operators. Okay, let's actually dive in and see what this problem is asking us. So as usual, we've got a wonderful story describing this problem. What it boils down to is basically that we have a list of strings. So we have basically several lines of text, and each of these is meant to represent a password as well as sort of like a protocol for that password, like a rule set for it. And so the idea is that in this case, for example, this password, the password that comes after the colon here, should have 1 to 3 A characters within it. So if it has fewer than 1 A, or if it has more than 3, it would be considered invalid. So since it has 1, this one is considered valid. The next one should have 1 to 3 B characters, but it doesn't seem to have any. So this one would be invalid. And then this final one here, it has 9 C's. And it's supposed to have between 2 and 9 C's, so that does pass. Now, one thing I just want to say, I really like the sort of efficiency of this example over here. They're showing us not just how to do this, but also they're incorporating the edge cases, if you think about it. We can see that if there's exactly 1 or if there's exactly 9, like if it's exactly the minimum or maximum value, it should still be considered valid. So I love an example like that that actually answers those kinds of questions that we might have. Okay, so let's dive into our solution over here. Actually, before we solve it, we should probably take a look at what our input data is. So I'm going to click this and we get a whole bunch of this. I actually have a Google Translate thing popping up because it doesn't recognize the language here. I'm just going to copy the first few lines of this time. I'm not going to actually go through the entire thing. Part of the reason is because last time there ended up being quite a bit of stuff on the screen. There was like a very long array, and I'd sort of like to avoid that this time. Okay, so I'm going to do, I think it was Alt-Shift-I. Yeah, there we go. And so I'm going to, okay, first of all, let's make these strings. Okay, so far so good. And then let's put them in an array together. Okay, nice. And we'll just say const list is assign the value of this. Did I put a semicolon? No, there we go. Okay, so let's just save that. Great, okay, so we just have a little bit of sample data here. The reason I'm only taking a small sample this time is I figure today's going to be all about data manipulation, and so it might actually be a good opportunity for us to talk about other ways that we could actually get this data, ways that we could get it a little more directly, and that's where the Fetch API is going to come in. There's still a few unknowns about that. I mean, unknown to me, so I might have some questions for you about it. So look forward to that, I guess. But for now, let's actually try to solve this problem. So since we're talking about strings here, I'm thinking this is going to be a good opportunity for us to use regular expressions. Now, if you're unfamiliar, regular expressions are basically like a miniature programming language. Okay, so you can use regular expressions within contexts outside of JavaScript. I believe most programming languages allow the use of regular expressions. What are they? They're basically just like very, very terse, very like dense strings that represent patterns. And so we tend to use those to sort of match strings that fall into certain patterns. So for example, in this case, we know we're going to have some number of digits, right? We're going to have a hyphen character right after that. And then we're going to have some other number of digits. We're going to have a space character. We're going to have a single word character, or I think it's a word character. we're going to have the colon symbol, literally. We're going to have a space again, and then we're going to have some number of characters. So notice, like, we don't know exactly what these characters are going to be. We don't know exactly how long the string is going to be, but we know that it's going to adhere to some kind of pattern. So for regular expressions, this is a very common use of them. We're basically just going to try to come up with an idea of what the pattern is. So I'm just going to say const. I guess I'll just call it pattern for now. There might be a better name for this, but when we're inserting a regular expression into JavaScript, one of the ways we can do it is to use forward slashes and then sort of enclose what we want to have in here. So what I'm going to say is \d. That means that this is going to be a digit character. Okay, so this would match with like the 7 over here or the 5 over here. I want to consider the case that maybe there might be more than one digit. So in that case, I'm going to say plus. This basically means there's going to be one or more of these characters. Now keep in mind, all of this regular expression stuff, if you're unfamiliar with it, this is independent of JavaScript. So what I'm doing right now is not JavaScript stuff. In fact, we could do this in a much more JavaScript kind of way, right? Like we could do a dot split and split on the space characters in order to sort of extract the different parts that way. That's fully doable. And it might even be the more efficient way of doing it. I'm not exactly sure. But we're going to use regular expressions for this. They're a good thing to have experience with, a good thing to have in the bag of tricks, so to speak. Okay, so the next thing is we want that hyphen character. Now, sometimes in regular expressions, certain characters like the dot have special meanings. And so in order to avoid any potential special meaning that this hyphen character might have, I'm going to put a backslash in front of it. That might not make a difference. It might not be required, but it's probably not going to cause any harm. Okay, so we've got the hyphen. Now we have some number of digits again, so \d. And then we're going to have the space character, literally. So I'm just going to put in the space. And then I'm going to assume this one is going to be a word character, so \w. And then again, we have another character that I'm not sure if it has a special meaning within regex. And so I'm just going to put a backslash in front of it just to be safe. We might remove those later. And then another space. And the last part of this is going to be some number of not necessarily word characters. What we know about them is that they're not going to be white space characters. So the way we would do a white space character would be a \s. I think it's S for space. And then basically, since we want something that's not a white space, we're going to use capital S. And that sort of convention applies to these other ones too. So if we wanted something that was not a word character, we'd use capital W. And if we wanted something that's not a digit, we would use capital D. With the backslash in front of it, of course. Okay, and now we know there's going to be more than one of these things, so we're going to put a plus. And it's kind of funny because at this point, like this doesn't really look intelligible. In fact, it looks pretty comparable to one of these little designs over here. But I promise you, this actually holds some meaning. There's, there is some intelligible information here. And so just to sort of test that, I'm going to use one of my favorite online tools. So I'm going to go over to regex101.com. And this is a regular expression tester. So basically we can put in our regular expression and it's going to break it down for us. So it's going to tell us about the different parts, what all of these represent. Hopefully you can see the little mouse over pop up here. So basically the idea, like we were saying before, this is going to match any non-white space character. This one is going to be any word character. It gives us sort of more specifically what that means. So A to Z or capital A to Z, 0 to 9, or even the underscore. Okay, so basically at this point, I want to actually test this stuff. So let's grab one or maybe a few pieces of our sample data. And we'll see if this, wrong thing. We'll see if this matches any of these. Okay, great. So we have a lot of matches. Each one of these is matching up nicely the way we would want it to. And by the way, it's matching multiple of these because we have the global flag on. So if we only wanted to match one, we could take that off. In fact, we probably will end up not using the global flag. If we wanted to use it, we would actually have to add that to our code. Just put the G character after the regular expression. But I'm going to say this time we probably won't have to worry about that. So we could do something like this. We could say, okay, first of all, I'm just going to say console.log list, just to make sure this is working. So I'm going to save this, and now I'm going to run the code. Okay, great. So we're getting a console log of this list. And now I want to do something a little bit different. So I'm going to say list dot map. Okay, so we looked at dot map last time. It basically is just going to go through an array like this list over here. And then for each element, which I'm just going to call these each PW for password. That's just a placeholder for now. You can call it whatever you want. But the point is each one of these is going to be PW at some point. So for the first one or the 0th one, this will be PW. Then for the next one, this will be. Okay, so basically what I'm trying to do here is I just want to say, I want to test this against our regular expression. So I believe that's a regex built in. So it's going to be pattern.test, not text, test PW. Okay. So basically this should return a Boolean. It should just say whether or not there's a match with this regular expression. So I'm going to save and run the code. And now if we look at this, true, 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 true. Okay, great. They're all true because they all match. So all 7 of these are a match to this regular expression. So that's nice. That's a good sign. That's what we're looking for, right? Now I want to do something a little bit different. I want to introduce something new into our regular expression. So specifically, it's the idea of a capture group. So we could get some information out of this, but it's not really all that useful just to see if it matches up with the convention here, because we kind of already know that it matches up. Like we designed this regular expression after looking at the patterns over here. So, okay, going back to this, basically what we're going to do is extract some of this information. So this first set of digits, notice as soon as I put these parentheses around that, now it's the first capturing group. So you can see the 3, the 7, the 7, the 4, it's capturing each of those. And we can see over here in our matches, we've got group 1 for each of these things. Okay, well, we want more than just that. We don't really care about the hyphen. That's going to be the same for every one of these. We do want to capture the next digit. And actually, sorry, I shouldn't say the next digit, the next number, actually, because it could be multiple digits, as it is in actually almost all of these. So we can see that now we have the full match. We have group 1, we have group 2, and we're going to have more groups because I want to capture the character as well that we're trying to match to, and I want to capture the actual password itself. Okay, so now we have 4 matches for each one of these things. Oh, it's so nice and colorful. It looks great. Okay, good stuff. And maybe we can even simplify this a little further. So I'm noticing if I mouse over here, this matches this hyphen character literally. If I delete that, does it change the meaning? It looks like it still matches this character literally. So I think we're not going to have any difference if we change it to this. So yeah, and we'll just verify. Yeah, that seems to be the same. Okay, so basically I'm going to go over here. I'm going to modify our regular expression. I'm going to paste in what we had over here. And now I'm just going to save and run this again just to make sure it's still matching these. Okay, great. So it's still matching them, but now I actually want to flip this around. So I want to use not a regular expression built in. So keep in mind this dot test is something we could use with any regular expression. A regular expression is a type in the sense that, like, you know, a number or a string is a type. A regular expression is a type as well. So it's a type of object. I'm going to switch over to the full IDE mode over here, just so we have a little more room to work with. Great, because I think this is going to get a little bigger. Basically, what I was saying is that test is built in for regular expression. What we actually want to use now is a built-in for strings that can accept a regular expression. So I'm going to use the dot match built in, and I'm going to put pattern in. So notice we sort of flipped it around. Before it was like pattern.test of PW, and now it's PW.match of pattern. So that can be a bit of a tricky thing, remembering which one goes with which in terms of these built-ins. But if you're unsure, you can always look it up. Okay, cool. So check this out. We're doing this map, and now the information we're getting out of it is a lot more massive. We're noticing that we have basically 5 elements here, which I guess no surprise, because if we compare it to what we had over here, we had the full match, group 1, group 2, group 3, and group 4. And notice that's kind of what we're getting over here. Or I shouldn't say kind of, that's exactly what we're getting over here. So we want to basically capture each of these things. Now notice that this is an array, right? So we could actually break this out and say, okay, we're going to do more stuff with this than just a simple return. So let's actually say something like this. Const parts is assign the value of this thing. And then we could say like, you know, const minimum is parts at 1 because it's the first group, and const maximum is parts at 2 because it's the second group. And then, you know, etc. We could say the character is parts at 3, and that the actual password is parts at 4. Okay, we could do something like that, and then we could just say, let's go with return min, max, character, and password. Okay, we'll just do something like that. And what we should expect to see here is basically that this, well, it's going to look similar to the list that we have down here. The only difference is that this, well, we won't have like this index input, that stuff down there. It's just going to be actually these 4. That's what we should expect. So let's go down to the bottom so we can see our new output. And here it is. Okay, yeah, so that's a little nicer. It's a little more organized. We have direct access to our min, max, character, and password. And I think that this could actually be a little more efficient. In fact, I think it could be a lot more efficient because we can use a destructuring assignment to assign all these things. So we could do something like this, that this is just parts, right? This is assign the value of parts. The only problem here is, keep in mind, we're actually starting at element 1, not element 0. So we need to have something in the element 0 spot. So I'm just going to say full match, and I'm not actually going to use that. So it's going to gray out the text here. We could even just put like, you know, a little underscore to represent that we're not using this variable. We just need to have it there for the destructuring to work properly, right? Because otherwise it's going to assign the full match to min and then the min to max, etc. Okay. So basically this destructuring should work the same as that. So that's like a lot more efficient, right? So let's save that and run it. Same thing, it looks like. Yeah, good stuff. So that shouldn't be a problem. And in fact, like parts, do we really even need a variable for that? We're only really using it once, I think. So let's just put this directly in here, and right as we do the match, we're breaking it down into its parts. I'm going to change the name of this because I think having password and PW might be a bit confusing. So I'm actually just going to call it entry, just to be a little more accurate. Okay, cool. So great. This is looking good. And let's see. What else do we want to do with this? We've got the min, the max, the character, the password. All of that is pretty good. Maybe what we can do now is actually solve the problem, I guess. So what we're trying to do in the solution is to tell is the number. Okay, so I'm just going to use this as an example. Okay, so looking at this string down here, count how many of this character we see. Okay, so in this case, the L character. Is it between this number and this number inclusive? So we have all that information. We should be able to actually process it. So basically, here's what we're going to do. I'm going to say const character count. Okay, we're going to count how many of this character is actually appearing within this string. And the way I'm going to do it is, I think, very inefficiently. We could use like another regular expression or something for this, but I'm just going to do a bit of typecasting stuff, and I'm going to use another array built in. So we looked at filter last time. We're going to use that again. So the first thing I'm going to do, because I want to use filter, I need for this thing to be an array. So I was just about to type out an array, but we could do something like this. We could, we have typecasting kinds of things like .toString or parse int and that kind of stuff. But I'm actually just going to use destructuring and the spread operator for this. So the spread operator is basically going to take, whether it's a string, an array, it basically has to be some kind of iterable, but it's going to take that iterable and just break it all up. So it's kind of like almost like dissolving away the array part of this or the string part of it. So basically the moment I do this ... it's basically just breaking password into each of its characters. And then I'm capturing those characters inside of an array with these square brackets around it. So that's kind of weird. And especially because I'm not actually going to do anything with this array. The only reason I want it to be an array is so that we can use filter. And basically for this, I'm just going to say whatever the character is. I think I've already used, actually maybe I'll call this one character just for clarity. And that means we'll have to change the name of this one over here. Maybe we'll call this target character. Just to be really specific, target character. Okay, and that means, whoops, we'll have to change this down here. Well, actually, we'll be changing that completely in just a sec. But anyway, we'll just say if character is equal to target character, then we're going to keep it in the array. Otherwise, we're not going to keep it in the array. So what we should get from this character count array is basically just an array of all of the target characters. So like in this case over here, it would just be all of the L characters in here. And you can see it's kind of highlighting that there are 4 of them. So this one should pass. It has the minimum number. Okay. But keep in mind, we don't want an actual array with all of those L's in it or, whatever the character is. What we want is just the length of that. So I'm kind of stringing together quite a few things here, maybe to the extent that it's uncomfortable, but we'll see if it's actually working. We'll just say character count. Now, in terms of finding how many characters there are, or how many matching characters there are in the string, that's the sort of thing that there are a lot of ways to do that, right? So you can probably think of lots of creative ways. We could use a loop or something like that. We could use a regular expression, but I'm just going to stick with this filter thing for now. I think it's good enough. Okay, cool. So basically, it looks like our character count is accurate. We've got 3 J's over here. In this case, we have how many H's? I'm going to believe that it's 9. I don't want to go through and count each individual one. But yeah, it looks like this is actually matching up. It looks like the character count of this is actually working. Okay, cool. It is a little bit long here to the extent that it's breaking onto the next line. But anyway, we won't worry about that for now. So what we want to know actually here is not all of this stuff. What we want to know, well, actually, I'll do this one step at a time. So we want to say basically if this has the right number of this target character, then we're going to, return true. Otherwise, we're going to return false, right? So we could say something like this. If I'm going to say parse int of min, and this is really important because this is by default going to be a string, and the way a string would be compared in terms of this like less than or equal to is going to be different from the way an integer or a number would be compared. So yeah, this is basically the condition. If the character count is within this inclusive range of the minimum and the maximum number. Okay, so if that's the case, we're going to return true. Else, return false. Okay, so let's run that. And okay, so it looks like the first one is true. Yeah, I agree with that. The second one also true. Yeah, and if there are 9 H's, that makes sense. This one, how many J characters? I think we only had 3 J's, so yeah, it makes sense that this one would be false. Next one is passing. Yeah, it looks like it has the right number of L's. This is looking good, so I believe we're getting the right answer here. So if we think back to the strategy we've been using for these, I think we're just about at the point where we can make it work. And so we've talked a little bit about making it efficient. That's going to be less of a concern for this one. In terms of making it beautiful, I think there's some work to be done here. So I talked about how one of the things we want to talk about is sort of like common patterns for programming. So this is one of the ones you might encounter a lot, this idea of like, well, if this thing's true, then return true, and otherwise return false. But think about what we're actually saying with that. So like this whole thing inside of the if conditional, like this is a Boolean. This thing is true or it's false. And we're basically saying if it's true, return true. If it's false, return false. Now, wait a minute. Why don't we just return this thing? Like it has the true or false value that we're looking for, right? So we could actually just say return this. I know it might look weird because it's got like, less than or equal to. It's got this like and here, this Boolean logical operator. But at the end of the day, this is just a true or a false. So if we run the code, there should actually be no difference in terms of the output. The difference in terms of the code, though, is striking. This is like, I think we economized like 4 lines just now, right? So this is pretty good. I definitely am, I'm really enjoying this, I have to say. Okay, so basically this is our list.map thing. By the way, I'm just going to put this over here and just say something like const result is equal to this, or is assigned the value of this, and then we're going to console log our result. Oh, and by the way, before we go any further, I wanted to give a special shout out to the user JSTask82, who had a great answer to my question from the last video. I was wondering if a console log would be considered a side effect in functional programming, and they believe that yes, it would be. And I think that makes sense. They had a great suggestion that if we really need to do something like that, where we need to console log and give some information that's not going to be included in the final value, maybe we could return this as an object. So for example, we could say something like, does it pass is going to be this thing. And then the second part of our object is maybe just going to be some additional information, like maybe we want to know just like the password that either passed or didn't, right? So we could say something like password, and then we could just say password. Okay, so I'm going to save that and run it, basically just to sort of show we can extract more information here. So instead of just doing like a console log of password in here, we can get all of that information returned as part of the function. So definitely that was a great suggestion. I really appreciated it. If anyone else has answers to any of the questions that I ask in these videos, definitely feel free to share those. I always appreciate them. Okay, so looking at this, yeah, does it pass? True, password was this. So this is a little nicer, this might be like the kind of thing that would be good for debugging purposes, or like if we were actually trying to tell if this thing was working in production. This would be good like reporting. Okay, so basically, what did we want to do with this? Well, in terms of actually answering the question, let's go back to what the question was asking. So we'll go to the split screen view. Yeah, okay. So basically they're asking how many of these passwords are valid. Okay. Well, I think we can tell. Basically, all we actually really need to do, I'm going to go back a few steps here, because the only part we really need to return is this, I think. So we could say something like this. Instead of returning result, we could say something like, okay, check this out. We're doing a list.map, right? In other words, we're going through and we're converting each of these things into a true or a false. Let's change this. Since we're returning a Boolean, let's change this to a filter. And if you recall what that means, basically, as we saw in the last video, if one of these things returns true, it's going to keep the original entry within the array. If it returns false, it's going to remove that entry from the array. So what we should expect to see is an array of 4 elements, and it's just going to be the passwords, or actually the full texts here, the full entries that ended up passing. Okay, so only the ones that passed. So I'm going to save this and run it. And now, yeah, just like we expected, we have 4 of these things. It seems like these are the ones that passed. We don't have any of the failures here. So this is good. Okay, nice stuff. Now, the only issue is, one more thing. We don't actually need to know the actual results here, right? We don't need to know whether these things are true or false. We just need to know how many of them were true. So I'm just going to put a dot length. If you think about it, this is actually very similar to this dot filter, dot length pattern we had over here. So that's nice. We're getting extra mileage out of that trick. Okay, cool. So the answer is basically just 4. There are 4 valid passwords here. Now, of course, we're not looking at the full list. We only grabbed the first, I think, 7, and I think there are actually 1,000 entries in the list here. So I didn't really want to congest our code with that full list. So maybe I should have actually just called this like sample list or something like that. But anyway, the main thing that I want to do here is I want to talk about how we can actually extract this information in a more direct way. Okay, so we're going to do this. We're hopefully going to feel like a real hacker when we do this. So this is where the JavaScript Fetch API comes into play. This is something that we would use for things like calling a backend route in a web app, or if we wanted to, for example, make a call to like the Google Maps API to find some information about a location or something like that. We would usually use fetch for those kinds of things. Now, there are some issues both with using fetch within Node as well as something else we're about to see. It basically, the fact that we're authenticated here, we're logged in on the screen. We're not really logged in over here, so I'm not going to do the fetch stuff here, at least not yet. I'm going to do it here. So we've brought up our little console window. I did a Control-Shift-I to bring this up. And basically the idea is we're going to use fetch to get our puzzle input. So I'm just going to copy the link address for this get puzzle input link. And I'm just going to say const response is assign the value of, and we just say fetch of this thing over here. Okay, response is that. Now, if we do that, response ends up being a promise. Well, hold on a minute. That's a little weird. We're getting into this idea of asynchronous code. Okay, so asynchronous basically just means that when we call this fetch thing, it might not have the result right away. It might need to wait like a few milliseconds to do some other calculation. Maybe it needs to do like a database lookup or something like that, right? It needs to make some sort of call. It needs to communicate with a server somewhere. And so it might not be ready right away. So we could do like a response.then and say like with the data, we want to do a console log of whatever that data was. We could do something like that. Or we could just do something like await response. Okay, so async and await, this is kind of the more modern way of doing this stuff. I'm actually just going to refresh the page because I want to start that over with a proper await on it. Okay, so it is an asynchronous event, so keep that in mind. Whoops, const response is going to be await, fetch, and then that URL that we had before. Okay, so basically now instead of getting a promise, we should get an actual response. Yeah, so notice our response has like lots of info in it. But I want this response not in the form of an object. I actually want the text of it. So I'm going to say response text is going to be assigned the value of await response.text. And you might be thinking, hey, I think you're going a little overboard with these awaits. I don't know if we really need it over here. And actually, as it turns out, we do. So .text, .json, like these ways of processing the data, for whatever reason, these are actually asynchronous as well. Okay, so we've got both of these now. Let's take a look at our response text. Hey, that's looking pretty good actually. So we've got the entries here. Notice this might be a little hard to see, but we have kind of like a little return character representing a new line. So we could do something like response text dot split, and then I'll put a \n over here. So this is just going to split on every new line character, and yeah, nice. Okay, so we get a 1001 element array. Why is it 1001? Let's take a look. So yeah, check it out. The 1000th entry is blank. Why do you think that is? Well, maybe it turns out that our test data ends with a new line character. Yeah, it looks like it does. So basically the idea is that since that ends with a new line, when we do this split, it's actually just gonna create this new element here. So we could just like lop that off with a .pop or something like that if we wanted to. But another way we could do it is something like this. I'll just say const full list, not to be confused with list that we had in our IDE window. Full list is going to be assigned the value of, basically our response.split on the new line character. But before doing the split, because we know there's an extra new line at the end, I'm going to do a dot trim. Okay, so we're going to trim the string just so that there isn't any white space on the ends, no leading or trailing white space. We're going to do that before the split, and that way we should actually just, response. Oh yeah, I did it on response instead of response text. Okay, well, hey. Look at how useful our little console is here. You know, it's giving us such nice, helpful information. It's true, response.trim is not a function. Response text.trim, on the other hand, should be. Oh, but we've already defined full list. We're going to call it fuller list. And there we go. So fuller list. Notice it now has 1,000 entries. And if we look at these entries, let's actually take a look at them. They actually do look like what we had over here. They look like the same entries that we had in this list. That's good. That's what we were looking for, right? Okay, great. So this is nice. The only thing that's left to do is to basically run our code, right? We want to basically just do all this. We want to say what the pattern is. We want to do our result. The only difference is instead of list, now it's going to be fuller list that we're going to do this filter on, and then we're going to console log basically, yeah, the result of that. So I'm just going to take this part first of all, and I'm going to paste it in over here. So keep in mind, like fuller list, response. Sorry, I should have introduced this earlier, but this is our console. This is something that's built into our web browser, and it's a place where we can just type in arbitrary JavaScript. We could do this to just do something as simple as like 2 + 3, and it's just going to say 5 right at the bottom. Oh, actually, I don't know if you can see that on your screen. Yeah, so 2 + 3, and it's going to say 5. Or we could do something more complicated, like, well, the stuff I'm about to paste in. It could be all of this. Another thing we note is right here. So this error that says full list has already been declared, that sort of indicates something really important, which is the fact that basically it's remembering these constants. Like it's holding these things in the namespace. So it still knows, like not all of these commands are independent of each other. It's actually why I refreshed the page earlier. So fuller list is what we want to have in here. And basically what I'm trying to say is that fuller list, if we just started with this, it would be like, what the heck are you talking about? I don't know about any fuller list. But since we defined it above already, it's in the namespace, it's going to know what we're talking about. So I'm going to hit this. It says undefined, but that's because we didn't ask for anything here. So we've just assigned a few things. So result. Okay, result, it says 483. Okay. I trust you, so I'm going to say 483, and hopefully that is the correct result. It'd be very embarrassing otherwise. Okay, great. So here's the downside to this. We got through this problem, and nice job, but it kind of cleared all the stuff that we had in the console. So you remember how I was saying it kind of remembers that stuff in the namespace? Well, there's sort of a limit to that. So basically, we're going to have to do some of this stuff over again. But let's wait for that because we need to actually solve part 2 of the problem, right? So part 2 basically says, oh, whoops, I forgot what it actually meant here. I forgot what this protocol meant. It's not that there's supposed to be between this and this many of this character. It's actually supposed to be that if we look at the one-based index of these two characters, of each of these two characters, exactly one of them should be equal to the required character here. Okay, so basically we're going to make a change to this over here. Actually, hold on, before we change this, were there any alterations we wanted to make? I think this is purely functional. I don't think we're having any side effects over here. So I think I'm happy with the way this function's working, or sorry, the way this command is working here. So let's actually move on, and we'll just try to find the new answer. So basically, what we want to do in this case is instead of min and max, oh sorry, I just hit the microphone. Instead of min and max, now it's basically going to be index 1 and index 2. Okay, so I'm just going to say index 1 and index 2 instead of min and max, because they don't really represent min and max anymore. And I always want to make sure that my variable names are actually semantic, that they're actually describing what that thing is. Okay, so basically we've got index 1, index 2, and what we want to know is not the character count, but we could even just say something like this, like const character 1 is going to be assigned the value of whatever the password is at index 1. And character 2 is going to be assigned the value of whatever the password is at index 2. Okay, cool. And then basically what we want to return, what we want to return is character 1 equal to the target character? Or is character 2 equal to the target character? Right? We want to return something like that. And I'm going to remove the dot length over here, because remember that is, if I have dot length, it's just going to tell us the number of correct passwords here. What we want to know is actually more what the correct passwords are, so we can verify that we did this correctly. Okay, so if we're looking at this one, 3 and 4. Oh, let me switch over to my full IDE mode. Sorry about that. Okay, whoops, that's not what I wanted. This is what I wanted. Okay, so basically we've got character 3 and character 4. That would be the J and the J here. Now, it does say it should be exactly one of these, not both of them. So that could be a problem. Maybe that should not be true. So let's alter this a little bit. So we want to say this or this. And then I guess also we want to say and not both of them, right? So we want to say it's one of them, the one or the other, and it's not both, okay? Not both. So we'll say and not character 1 is target character and character 2 is target character. This is getting messy. I'm starting to not like the look of this big Boolean. So let's do this, and it didn't really change anything here. That could just be because of the test data that we have. Actually, yeah, this or this and not this and this. Well, I'm actually kind of surprised by that, because shouldn't this first one return false now if I'm saying and not that? Wait, am I looking at the right result? Let me just verify that. Okay, so this is interesting. I am going to do a console log, but I promise I'm going to remove it later. I just want to actually know what character 1, character 2, and target character are. That might be useful. So let's take a look at this. Yeah, okay. Yeah, maybe it would have been better. Oh, yeah, okay, so check it out. We're actually getting some weird undefined stuff happening in here. That means we're probably not doing the indices correctly. Something to remember is these are the one-based indices, right? So if we look at the task description over here, this one, like when they talk about position 1, they're talking about like, index 0 over here, right? Which they make a note of pointing out they don't have this concept of index 0. So that should have been a good hint that we need to adjust these indices. And I love that they bring that up, because that's such a common thing in programming, that we have these off by 1 errors. Okay, so we're going to save that. We're going to run the code. Oh, I might have made a mistake over here. So let's try running the code. And there we go. Okay, so now we're getting a completely different set of responses here. So let's see. J, J, and J, that one I guess was false. G, P, and H, yeah, that would be false too, because basically exactly one of these needs to be the H, exactly one of these needs to be the J. So these two are false for different reasons. And then this one over here should be true. So it's got an S, a J, and yeah, basically exactly one of those is a J. So I think that's this one over here, right? That if we look at character 7, yeah, that's an S. And if we look at character 13, which is probably this one, it's a J. So yeah, it seems to be working here. The thing I don't really like is that, well, first of all, let's get rid of this console log. It's bugging me. Okay. And then basically this, it's messy. There's a bit too much stuff here. I would really like something a bit more efficient. Now, I don't think we have a Boolean operator for what we call XOR or exclusive OR. Basically what that would mean is that either the first thing is true or the second thing, but not both. Whereas like this OR character is saying either the first thing or the second thing or both. So instead of this, I'm actually going to use a bitwise operator. Okay, this is maybe going to seem a bit weird, and it's especially weird if you expect this to be like an exponentiation, like to the power of. I know it's sometimes used to represent that, but not in JavaScript. We would use a double asterisk if we wanted that. But in this case, basically what this is going to do is it's a bitwise operator. So because these are Booleans to begin with, the two parts over here are Booleans, it's going to convert those to binary numbers. It's going to perform this bitwise operator on those binaries, and then the result, since we're doing a filter, is going to get typecast into a Boolean. So JavaScript, it's loosely typed and it loves to do these automatic typecasts for us. You know, if we give it the wrong type of data, it's going to be like, oh, no problem. I think I know what you meant. So basically that's what's going on here. We're kind of relying on that. If we really want to be airtight about it, we could say like parse int of this, and then XOR parse int of this other thing, and then convert that to a Boolean at the end. But, you know, I think I'm okay with this. So, well, I should check that it's actually working before I say that. Okay, so I think it's probably working. It seems to be matching up. Like, we're getting the same answer over here as we are down here. So, yeah, I think we can be somewhat confident that this is probably correct. You know, if you wanted to, we could say like, we're not really using character one more than once now. So we could just replace this with the definition of character one. And then similarly, we could do the same thing with character two, and then basically just delete those two lines. So yeah, that's probably falling under category 3 more so than category 2, but you know, like it looks nicer. I think this is nicer than what we had before. We'll just run it one more time to make sure it's still working. Yeah, nice. Okay, so now at this point, I think we're just going to go back to our split screen. And yeah, we've got our console open already, so this is good. Oh yeah, one last thing I wanted to change over here is we did want to put the dot length back on this because we want to know the number of correct entries, not the correct entries themselves, right? Okay, so going back to this, keep in mind, we lost our response, right? If we say like response text, it's going to be like, I don't know what you're talking about. So we're going to have to redo the actual fetching part of this, but you know, that's okay. That's okay. We'll just copy the input. This way we get to feel like an elite hacker all over again. So I'm going to say const response is assign the value of await, fetch, all this stuff, and there we go. We'll say const response text is assign the value of await response.text. I think eventually I'm going to write these out inside the IDE as well. Maybe we'll just stick them in a file because we'll probably do this, you know, more times in the future. Okay, so we've got response text, which was response.text, and now we want to get the list, right? So I'm going to say const list is going to be assigned the value of response text. Remember, we're going to do a dot trim on this one, and then we're going to do a dot split on the new line characters. And we're doing that dot trim so that we don't get like just an empty character at the end or an empty entry at the end. Okay, so there we go. And list, let's just make sure that looks right. It's 1,000 entries, and they seem to be the ones that we're looking for. So all we need to do now is basically just take this pattern and result thing. And by the way, like if we wanted to make this, yeah, a step more condensed, we could basically just copy this in here. Like we're only using pattern once, right? So we could just put it directly in there. But I don't know. To me, that's starting to feel a little more messy, to be honest. So I think that would be a matter of personal taste. Okay, so going back to this, I just want to paste this in, and even though last time we had to make this alteration, this time it's fine because we actually called this thing list. It's not like full list or fuller list or anything like that. Okay, so at this point, I'm just going to hit enter, and we should get a number, I think, right? Or no, we should get an undefined because I'm not asking for anything, and now I want to know the result, and it's 482. I think that's actually quite similar to the last one we had. But, you know, a law of large numbers, right? Okay, so 482. What do you think? Are we confident enough in this? Let's give it a try. It's the right answer. Okay, great. Good stuff. So, just like in the last video, I have a question for you, dear viewer. I'm wondering, do you know a way I can do this fetch stuff within my IDE? I mean, it's really nice that we were able to actually get that authenticated request working, but I'd love to be able to just sort of send my credentials through the header of the fetch request that I'm making. I'm just not really sure how to do that yet. So I need someone who's like actually an elite hacker who can help me figure that one out. So if anyone has any suggestions on that, I'm definitely interested in hearing about it. In the meantime, congratulations. It looks like we crushed another one of these. It was very satisfying. I hope you'll join me again in the next video. We'll continue on with day 3 next time. And between now and then, I guess, remember to believe in yourself. Anything's possible. Bye.